radian measure. So, what is a radian? A radian is an angle of a circle that intercepts an arc equal in length to the radius. Right? It's a unit for measuring an angle, similar to a degree. So if you look at this GIF, wait for it to start over. But if we have the radius of a circle, and we have an arc length that is equal to that radius. So you start with the radius of the circle, and you have radius r, and we may have an arc length that is equal to that radius. Then the angle that makes with the center of the circle is 1 radian. Because the circumference of a circle is 2 pi r, there are 2 pi radians in a circle. So, a radian is an angle of a circle. It is 1 over 2 pi of a circle. So, 360 degrees equals 2 pi radians, one whole circle. Cut all that in half, we get 180 equals pi radians for a slightly more convenient conversion factor. So, convert from degrees to radians. You can do this as straightforward dimensional analysis, right? With your conversion factor being pi over 180. And just make sure you put your degrees in the denominator so your degrees cancel out. So you get 225 over 180, which is going to be 45 over 36? No. Yeah, 45 pi over 36, which is 15 pi over 12. Reducing fractions takes a minute, which is 5 pi over 4. All right, so 130 degrees times pi over 180 radians is going to give you 130 pi over 180, or 13 pi over 18. It is common to leave radians as fractions in terms of pi. If you look at your unit circle has radians as fractions in terms of pi. So pi over 2, pi over 4, pi over 3, pi over 6, etc. 147 pi over 180. 147 does divide by 3, which I think is 49. 49 pi over 60 would be the fraction in lowest terms. 42 pi over 180. That divides by 6 and is going to be 7 pi over 30. And then to convert from radians to degrees, we just do the same thing but backwards. Instead of multiplying by pi over 180, we multiply by 180 over pi. So 3 pi over 2 times 180 over pi. Your pi's cancel out, and that's going to be 3 times 180 over 2, or 3 times 90 is 270 degrees, which is also on your unit circle. pi over 8 times 180 over pi is 180 over 8, which is 22.5 degrees. 4 pi over 7 times 180 over pi. Pi's cancel out. 4 times 180 over 7 is not going to be a whole number, but that's okay. It doesn't need to be. Is 102.9-ish. Two-thirds times 180 over pi. Here our pi's don't cancel out, but that's also okay. We can just plug it all into the calculator like this and come up with 38.2 degrees. Use your unit circle to find the following. It would have been smart if I had a unit circle on here. Sketch a unit circle. Right? 5 pi over 6, right? Pi is 180 degrees, which would be 6 pi over 6. 5 pi over 6 is going to be 30 degrees above that is going to be 150 degrees. And the sine here is 1/2. Pi is also 4 pi over 4. So 5 pi over 4 is going to be in quadrant 3. And the cosine there is negative root 2 over 2. Remember, when using your unit circle, that the coordinates of each point on the circle are the cosine and the sine, respectively. Negative pi over 3, we're going to go pi over 3 in the clockwise direction. That looks more like pi over 6. Pi over 3 would be more like here. So we're going to go pi over 3 in the clockwise direction. Negative pi over 3. And your sine there is going to be negative root 3 over 2. And then pi over 6. The tangent of pi over 6 is going to be the sine of pi over 6 over the cosine of pi over 6. The sine of pi over 6 is the y-coordinate, which is 1/2. And the cosine is the x-coordinate, which is root 3 over 2. And your 2's cancel, and you get 1 over root 3. Or if you rationalize that denominator, you get root 3 over 3. Radian measures are really helpful for finding arc length and area of a sector. So a circular arc is part of a circle. It is part of a circumference of a circle. It is often defined by the central angle that intercepts it. So this angle that this makes with the circle intercepts these arcs. The opposite of that, we say that an arc subtends its central angle. Central angle of a circle is an angle whose vertex lies at the center of the circle. Very straightforward. And so we get this nice handy little formula for the length of any circular arc, which is equal to the radius times the central angle measured in radians. So the radius times the number of radians gives you the arc length, and that's really handy. Right? So given a central angle of 128 degrees, find the length of its intercepted arc in a circle of radius 5 centimeters, round to the nearest tenth. So first thing what we have to do is we have to convert 128 degrees to radians. So multiply by pi over 180, and we could 128 divides by 4. That gets me 32 pi over 45 as my angle theta. And that's good enough. We can leave it as a fraction. And then the intercepted arc, S, is just going to be r theta. R is 5. Theta is 32 pi over 45. And you plug all that into your calculator. And you're going to get, to the nearest tenth, 11.2 centimeters. You're going to be in the same units as your radius. Ta-da! Easy. Winnipeg, Manitoba, Canada, and Dallas, Texas lie along the 97th degree west longitude line. So they're both on the outside of this circle if we're looking at Earth from the side. The latitude of Winnipeg is 50 degrees north, and the latitude of Dallas is 33 degrees north. The radius of the Earth is about 3,960 miles. Find the approximate distance between the two cities. So this angle is going to be 50 minus 33, which is 17 degrees. Convert 17 degrees to radians. That's just going to be 17 pi over 180. It doesn't do anything special there. It doesn't reduce in any way. But now that gives us our angle theta in terms of radians is going to be 17 pi over 180. And then our length, our arc length, is just r theta, which is 3,960 times 17 pi over 180. 960 times 17 pi over 180, which is to the nearest mile, 1,175 miles. Now you could convert 50 degrees times pi over 180 and 33 degrees times pi over 180 to get two different angle measures and then find two different arc lengths and then subtract them, but that's a lot more work. Easier to find the angle, the central angle between Winnipeg and Dallas first, and then you only have to do this once. A sector is a region, it's a part of the area of a circle, the way that the arc length is a part of the circumference. So it's a part of a circle that the area of the circle that you get from a central angle and the intercepted arc. The ratio of the area of a sector to the area of a circle is equal to the ratio of its arc length to the circumference. So all of these things are proportional. And I like to think of this as the part to the whole. Right? The arc length is a part of the circumference. The sector area is a part of the total area. The angle theta is a part of 2 pi radians, or x degrees is a part of 360. So all of these things are proportional, and if you know 3 of them, you can set up a proportion and solve for a 4th. If theta is the measure of the central angle expressed in radians, and r is the measure of the radius of the circle, the area of the sector A is as follows. A equals 1/2 r squared theta. You get this by rearranging this formula. This is kind of the big formula, and if you use this to solve for the sector area, if you solve this part for the sector area, you're going to get 1/2 r squared theta for A. Again, theta needs to be in radians, so if it's in degrees, you need to convert it to radians first. Find the area of sector if the central angle measures 5 pi over 6 radians, and the radius of the circle is 16 centimeters. So A equals 1/2 r squared theta. R is 16. Theta is 5 pi over 6. Multiply all that together. It is literally that easy. 16 squared times 5 pi over 2 times 6. Put all that in your calculator. So the way that I put that in the calculator was 16 squared times 5 pi over 2 times 6, because the 1/2 and the 6 are in the denominator. And I put that in my calculator, that gives me 335.1 square centimeters. Our radius is in centimeters, our area is in centimeters squared. Junjira Puduwuthagul owns a business in Chiang Mai, Thailand that makes ornate umbrellas and fans. Miss Puduwuthagul has an order for 3 dozen umbrellas, so 3 dozen is 36. Having a diameter of 2 meters, which means the radius is 1 meter. Bamboo slats that support each circular umbrella divide the umbrella into 8 sections or sectors. Each section will be covered with a different color of fabric. How much fabric of each color will Miss Puduwuthagul need to complete the order? So the angle that this is going to intercept, right, is the angle is 2 pi for the whole thing divided into 8 parts, which is pi over 4. So the angle for just one of these sections, the angle theta is going to be pi over 4, and we know the radius, so theta is pi over 4. The radius is 1 meter. The area of one of these sections is 1/2 r squared, so 1 squared times pi over 4, which is going to be pi over 8 square meters. And pi over 8 is about 0.4 square meters. But that is only for one umbrella, and she has to make 36 of them. So multiply that by 36. And so 36 pi over 8 is equal to 14.1 square meters. Slightly different than multiplying this by 36 just because of rounding error. But if you did 0.4 times 36 and got 14.4, that would also work. I'd take it. Ta-da! Very easy. Great introduction to Chapter 6.